Hello everyone, my name is Aditya Ajmera. I'm the faculty for geography at Priyas IAS, and in this video we are going to discuss a very important topic from the geomorphology called plate tectonics. We will understand what are the theories which was given before this plate tectonic theory and how the landforms are evolved, and this concept is from the surface configuration of the earth, in which we will understand how the landforms like mountains, lakes, ocean are evolved on the surface of earth. And it was in 1850 there was a theory at that time, and this theory was called as theory of permanency theory of permanency, in which the scientist and the geographer at the time, they believed that all the structure, all the landforms like the mountains, lakes, plateaus are lies on the surface of earth from the beginning. That means when the earth was formed, these all structures was lies as it is as we see them today. And this theory was challenged in 1912. A German geographer called Alfred Wegener, he challenged the theory of permanency, in which he gave the concept of continental drift theory, in which he said that continents are not static, they are not as it is as we from the beginning. These continents are basically moving on the surface of earth, and this is why this theory is called as continental drift theory. Alfred Wegener gave different concepts like the supercontinent, in which he described that supercontinent. He described that around 225 million year ago, 220 or 25 million year ago, the Earth's surface had a large continent, and this continent was called as Pangaea. This continent basically was sum of all the continents we see today, and around 150 million year ago this continent divided into two parts, Laurasia and Gondwana, and then later on these two continents evolved in such a way that we see today on the surface of the earth. And Alfred Wegener also gave the concept of Sial and Sima. So these are the concept in which he described that the earth crust is divided into two parts. These parts are ocean crust, that is ocean crust, and other one is the continental crust. So basically earth crust is divided into ocean and continental crust. The ocean crust has the composition of heavier elements like silica and magnesium. And if we talk about the continental crust, we have the components like silica and aluminium. Aluminium have lower mass than the magnesium, and this is why the continental crust is lighter than the ocean crust. Ocean crust have higher density but less thickness compared to the continental crust. So this concept was given by the Alfred Wegener, and he's the person who challenged the theory, but he was not able to describe why the continents are moving, and this is why the new theory came, the seafloor spreading theory. And this theory was given by the Harry Hess, and it was given in the year of 1962. And according to this theory, the ocean crust, just below the ocean crust, there is some molten magma which we call the asthenosphere, the upper mantle layer, which we call the asthenosphere layer, in which he described that this magma is exerting some kind of pressure on the ocean crust. This is why the ocean crust is getting separated, and these ocean crusts are moving apart. The continental and ocean crust are joined, and these are moving apart because of the pressure exerted by the magma just below the ocean crust. This concept was given by Harry Hess, and Harry Hess was basically the marine geologist, and his focus was more on the ocean crust. But this theory was not able to explain how the landforms are evolved on the surface of the earth. And although he gave the concept of spreading, but not clearly we can understand the formation of the landform. And then later on, a new theory by the Arthur Holmes was given, and this theory is called as convectional current theory. So as we have discussed earlier, just below the ocean crust, uh, the crust, we have the mantle layer, the asthenosphere, and the lower mantle layer, in which there is the huge amount of molten magma. And this molten magma is because of the radioactivity, because of the density adjustment, the molten magma is moving upward, and this molten magma is moving in a circular path from the crust to the outer core, and this circular path makes a convection. So we can understand, just below the ocean crust we have the circular pathway of the molten magma. Because of the radioactivity, the density adjustment of the material, and this magma is moving in a circular direction, which we call the convection current theory. Then later on, a new theory was evolved, the plate tectonic theory. If you want to write the answer for the surface configuration of Earth, you have to take help of plate tectonics, because it is the most scientifically valid theory, and it not just explains the first order landform, but also the second order and the third order landforms, like the mountains and how they are arranged. It also explains the distribution of island, archipelago. This theory subsumed the seafloor spreading theory and the continental crust theory, and this theory was given by the Jason Morgan, and he explained that he just denied all the earlier concepts, uh, which include the Sial and the Sima, and he gave new concept of lithosphere, in which we gave the concept like lithosphere is the outermost layer of the earth, and this lithosphere, just below the lithosphere we have the mantle layer, and then we have the core. So lithosphere is basically divided into several parts, and these parts are moving here and there because of the pressure just below the crust. So these parts of the lithosphere is called as plates, and the movement of plates because of the pressure exerted by the convectional current below the ocean crust, this will give the movement of these plates, and the movement of these plates is called as tectonics. And this is why this theory, the movement of plates, is called as plate tectonics. So this theory was given by the Jason Morgan, in which he described the plate tectonic theory, and this is the most scientifically valid theory. We have the three different layers, three different kind of boundaries. The first is the divergent boundary. Divergent boundary in which the two plates are moving apart, moving like these two plates are moving apart in opposite direction, and from beneath these layers we have the molten magma coming out on the surface. And this is why when this molten magma will solidify, what will happen, a new crust will form, and this is why the divergent boundary is also called as constructive boundary. So these plates are moving apart, and the molten magma will come out, and this will result in the new crust. Then the second type of boundary is when two plates are coming toward each other. They are converging toward each other, and this is why the heavier plate will move downward, and this process is called subduction, in which the heavier high density plate will melt when it will come in contact with the asthenosphere. This is why this plate boundary is called as convergent boundary, also called as the destructive boundary, because there is a destruction of plates in this kind of boundary. And the third one is transform boundary. Transform boundary is basically when two plates are neither converging nor diverging toward each other, they are just moving parallel in opposite direction. So there is no formation or destruction of any plate, but there are some kind of volcanic activities. So we can see that this is the map of different plates on the surface of Earth. We have the major plates and the minor plates. We can understand these are the minor plates like the Caribbean plate, and the major plate like Pacific plate is moving toward the North American plate, and this is why we have the Rocky Mountains from the north to south direction. And we can also see the Indian plate is moving toward the Eurasian plate, and this is why we have the Himalayas, the longest mountain range after Andes. So we have discussed the three plate boundaries on the surface of Earth, how these plates are moving, and what is the result